Hi there, I just want to give you a quick intro on what acids and bases are to remind you what they are, some definitions of them, and then how we name them. Alright, so thinking about acids and bases, there are really three different definitions of acid bases, and we put all those three definitions together. That's how we would define acids and bases. But the AP curriculum strictly says the Lewis definition, not Lewis but Lewis definition of acids and bases is not to be covered. So that brings us down to 2, which is great. So let's start with the easiest, the most comprehensive kind of way to look at Arrhenius, the Arrhenius definition. Arrhenius says that acids are anything that produce H+ ions when they're dissolved in water. Seems pretty simple. And bases produce OH ions when they dissolve in water. So something like HCl. When you put HCl in water, it dissolves, it makes aqueous, so H pluses are separated from Cl minuses. That makes it an acid. Or bases, like the lab we just did recently, barium hydroxide. Ba and OH2. When those things go into water, the barium separates from the hydroxides, and hydroxides are in water. That's a base. What they'll also do is called the H+ a proton, and that actually makes sense because it really is a proton. Just a hydrogen atom would have one proton and one electron. But when you have an H+ ion, that means you've lost that electron. So really all that's left is a proton. So you can call that, say that you have an H+ ion, you can say you have hydrogen ions in solution, or you can say there's a proton in solution, because it's really the same thing. So here's what we got so far. H+ producer, OH producer, acids and bases. Now Bronsted-Lowry is very similar, but just a teeny bit different when we go to the bases. Bronsted-Lowry would say that acids are still an H+ or proton donor. Same thing. Before we said Arrhenius was a proton producer. Proton donor, same thing. Bases, though, are when you accept a proton. So when you look at this one here, you can see that the HCl is definitely the acid. It gives its hydrogen to the water, the base. Let me show that to you in here. Okay, so if you look at the screen, the equation on the left, we're going to identify the Bronsted-Lowry acids and bases, and then conjugate acids and bases. So looking here, we've got NH3, we've got NH3 and water. What happens is now NH3 now is NH4 on the other side. He has gained a hydrogen. And if you gain a hydrogen, that's what a base is called, a Bronsted-Lowry base. We got a base. And the water here has lost a hydrogen. If you lose a hydrogen, you're called an acid. So I've got my base and my acid labeled. Now I want to look at the other side. My base will turn into my conjugate acid. And we call it the conjugate acid because if you go backwards on this, like if you look at the reaction and go backwards, we see that he's lost a hydrogen, and we know acids lose a hydrogen. So it's called a conjugate acid. Conjugate technically means joined together as a pair. So that English word kind of helps us see what that's all about. On the other side, if you look at the hydroxide here, he would be called the conjugate base. And that's because he was the acid, and now on the other side he's lost his hydrogen. Now he's going to act as a base if we reverse it. We can see if we reverse the reaction, the OH has gained a hydrogen, and that would be what a base does. So let's take a look at the other example over here. HCl has now become Cl-. He has lost a hydrogen. That's an acid. Acids are going to be really anything with an H out front. So that makes it easy. But water has an H out front, but is it going to be an acid or a base in this case? I can see that water goes to H3O+, so he's called a base. He has gained a hydrogen. So if you look at water on the other side, if he's gained a hydrogen, now he's called the conjugate acid. And my HCl goes from HCl to Cl, so now it is called its conjugate base. Alright, not looking too shabby. One thing you can notice, though, is that water was a base this time, and it was an acid this time. I'm sure you've heard of that word before, because that word is called amphoteric or amphiprotic. Amphoteric is a word I've used in the past. Amphiprotic is something that the AP would use too. So those two words are interchangeable. That means you can act as an acid or as a base. So looking at our HCO3, it could lose that hydrogen out front, or it could gain a hydrogen, it's a 1-. It could do either. HSO4, it has a 1-, so it would love to gain an H+, or it could lose this hydrogen. And of course water. Water is a classic amphiprior. It will do either. Okay, going back to the screen. So let's look at writing the conjugate acid or conjugate base of two different things. If I have HCO3 and I want to write the conjugate acid over here, that would mean the conjugate acid is the thing that's on the right side. That would mean this one is acting as the base. Base is on this side, conjugate acid would be on this side. So if this is acting on a base, it wants to gain a hydrogen. So it's going to take on a hydrogen and become H2CO3. And now that you've gained H+, that 1- goes away, and it's actually a neutral charge. So let's do the next one. SO4 2- is going to act as the base, so I can write the conjugate acid on the other side. That means it has to gain hydrogen. HSO4. You gain one hydrogen at a time, which means my 2-, since I'm gaining H+, will become a 1-. Look at the next one, conjugate base. So this is my acid, and I'm going to write the conjugate base on the other side. Conjugate base would mean I have lost my hydrogen, so the conjugate base here would be 1 less H+, would be Cl-. Taking a look at the next one, we could go either way. You could lose a hydrogen or gain a hydrogen, but here I'm asking you to write the conjugate base. That means this one has to act as the acid to make this one the conjugate base. So if it's going to act as an acid, I got to lose my hydrogen. I'll write just SO4 and have a 2- charge because it loses a hydrogen plus. So that brings us back to the screen, my summary kind of screen. You can see that the acids are always hydrogen producers, and a base could be a base if it's producing an OH or if it's an accepting H+. It could go either way. And if you put those two definitions together, that would be a definition of a base. Okay. Last thing we're going to cover here is how we name things. So you may or may not have known how to name acids, but here is my summary part. So if the anion, like HCl, normally if I look at Cl, the anion, I would call him chloride. Now if the anion normally ends in "ide," that's when you're going to make it hydroblankic acid, where that in-betweeny spot is where you put the chloride or whatever it is, chlor, sticks in there. If the anion ends in "ate," like this one is technically called sulfite, if it ends in "ite," then you're going to take off the "ite" and add "ose" acid, so it becomes sulfurous acid. And if the anion ends in "ate," like sulfate, chromate, nitrate, then you're going to take off the "ate" and add "ic" acid. Okay, let me show you what I mean. Here are my two examples that I have for you. What you want to do is first look at the ending part, the polyatomic ion or anion of any kind. So this one, according to my polyatomic ion chart, is called perchlorate. That's what it's called. Well, I noticed it ends in "ate." Anything that ends in "ate, I'm going to take off that "ate" and add "ic" acid. So this becomes perchloric acid. The "ate" now becomes "ic" acid. Take a look at the next one. Here's fluorine. Normally he'd be called fluoride. If you're going to become fluoride, what you're really going to do is you're going to keep this fluor part, and you're going to do hydrobleic acid. Because anything that ends in "ide suddenly becomes these parts. And then the fluor is just going to stick in here. Fluoric acid. I hope that helps. You can see the pattern there. I've given you a practice worksheet so you can kind of test yourself out and check out the answers. That one's just a practice sort of deal, I think. And the good news is, though, anytime we name bases, bases are named like everything you already know how to do, so you're set there, which is great. Alright, let me know if you have any questions.